Hello, and let's cut to the chase. Let's talk about Git. So we all know Git, right? It's the stuff we put our code in just to make it managed, versioned, and we treat it as a given. Like it's a normal requirement in current marketplace to have the knowledge of working with Git. So we tend to forget about its complexities. So I'd like to talk to you about the journey I've taken to getting to know Git and the problems I had while on it. So during that journey, I discovered one thing, that Git has three distinct characteristics that make it odd to work with. So the first thing is, like my university professor used to say, that it's created by IT for IT personnel, meaning its documentation is totally unreadable. Like, you can't get heads or tails of it. It's like trying to solve the chicken and the egg complex. Like, you read a definition, and you see a definition to define it. Second thing is that, and I'd like you to remember that Git is a console tool, meaning its basic interface is a command line interface, and that's the best way of interacting with Git. And also, it's the only correct way of interacting with Git. I know that there are certain tools that allow you to interact with Git through a UI perspective. I'm not going to be product placing this application. But believe me, in the background, they call a CLI commands on Git. And sadly enough, most of them do make mistakes on occasion. And if you end up in a world of pain with your repository, always remember that it's a command line tool, so revert to the command line. And the third odd characteristic is that it is not an online tool. And when I'm doing a Git training at Jeppesen, I always hammer these three rules to my trainees, because I'm going to show you later how that was a hard lesson for me to learn. So we know that Git is a branch-centric distribution system, right? So everybody heard about the master branch, about the development branch, and OK, I can do a commit, I can do a push, pull, fetch, I can do a merge, so I know Git, right? It's enough. So let me tell you a story about way back what I did as a developer. I started my working day. I did a git checkout develop, because that's where the development code is. I committed my work, I pushed it, and Git said no. Like, OK. So I'm sitting here looking at that error message, and I'm thinking, wait, I know what I'm doing, right? I know Git, so I did a force push. And as many of you can figure out, I went home. And the next day, my boss greeted me with a grim face, asking about certain commits gone missing from the development branch. Do I know something about it? And that's when I learned my first lesson about interacting with Git. First of all, no ninja pushes. And by ninja push, I mean don't do a push as the last thing you're doing during your working hours. Second thing, if you're using force to anything in Git, that means you're doing something wrong, even though it feels so good to finally get rid of that error message. It's wrong. So out of this lesson comes a suggestion: protect your crucial branches, as in the release branches, development branches, master branch. Most of the Git servers, be it Bitbucket, GitHub, GitLab, whatever, has a setting in the repository configuration that will allow you to disable force pushes, disable history rewrites. These options are there for a reason. Use them. And the last thing from here is, hey, use Git Flow. I mean, it's there for a reason. For those of you who don't know what Git Flow is a philosophy of branching within Git that evolved into a particular toolset. It describes the way you should interact with Git, how to create what goes into what branch, which branch gets merged into what, when do you delete one. If you don't know Git Flow, go and read up on it. It's really important, will make your life with Git easier. OK, so moving on. I don't know, have you ever found this out? Git lies. Seriously. So consider a situation like this. I did my work. I created my own separate branch. I committed my work. I merged it into develop. I removed my branch. And then my colleague is asking me, hey, dude, delete your branch. Well, I did it. No, you didn't. So I'm sitting at his computer, taking a look. Well, my branch persists. So I'm doing a git fetch. I'm pulling. Hey, my branch is still there. It shows it up as if it exists on origin. So, OK, your repository got broken. Reclone it. So he did. And then the situation occurred again, and again, and again. And that's when I learned something. Git is not an online tool. You're working on a copy. And a fetch is doing something odd, as in it only amends changes. It doesn't remove them. So if you want to be up to date with the origin, you need to use a prune with your fetch. It looks like this. Only this way, your local copy will be deprived of the references of the remote branches. And you end up having less problems with your repository. So now, I don't know, are you aware, but there's a very vigorous discussion within the Git Power user community. Should you use a rebase or a merge? And the biggest argument against merge is that your repository may end up looking like this. For those that haven't seen many branches graph cutout from a repository, that's one of them. Each line represents a separate branch, and if you're trying to search through history to find anything, you end up with problems. So if you're using Rebase, what you should remember? You should remember that you shall not rebase shared branches, because what Rebase is doing is basically deleting your commits, creating new ones in their place with a different originating point. So you are rewriting history. But if you're rewriting history in two different variants on the same branch, you'll have a very interesting evening at the office trying to resolve that particular conflict, believe me. So you shall not rebase a pushed commit, because if you're creating a new one in the place of the pre-existing ones, Git will tell you that you have new commits on the origin and on your local machine, and that just doesn't make sense. And one way around that is just to remove the remote branch and push it once again. But I know a situation when that went horribly wrong. So believe it or not, that's a real command in Git. It's seriously. If you end up in a situation when you have to reapply the same conflict resolution over and over again because you're doing some branch management stuff, that tool allows you to store that conflict resolution and reapply it over and over again to the same occurrence of the said conflict. And one thing to remember, rebase is a potentially destructive operation. And that's why for the most companies I've worked for, sooner or later there was a Git rebase ban issued because someone messed a resolution up and ended up breaking the product. So what did I learn out of it? Don't use rebase. Like, seriously, it's not worth it. You may end up breaking something hard. But if I can't use a rebase, how do we manage the situation of a repository looking like a spaghetti string? Hey, use Git Flow. It's there for a reason. And probably the obvious one, and the most neglected one among all the developers I know, I mean, don't leave your stale stuff on the origin. If you finished your branch, remove it. It's going to make life easier for you and everybody else. So one particular thing in Git that we need to do on occasion is Git archaeology. Meaning, you need to find when in time something got broken. Like somebody broke the build, or a client asks us when the particular change was made on a Git repository. And like, I'm a traditionalist myself, so I started eyeballing the graph. Like, I should be able to pinpoint it, right? Yeah, but if I'm being asked about the change that occurred somewhere between May 1st, 2018 and September 7, 2016, that's issued to tally about 2,000 commits, like, I'm not going to be eyeballing that. So I started using Git Reflux. Didn't help. So I started Googling. And that's when I learned something very interesting. I learned that something called Git Bisect exists. Git Bisect is a very neat command that allows you to do a binary search across your Git history, and it's really simple to use. You just say, hey Git, start bisecting. Then you're selecting the correct commit, the faulty one. And what Git does will check out a commit somewhere between these two that you've selected, and will wait for your decision. Is it a good commit or a bad one? So you're basically sitting here typing Git bisect good or Git bisect bad until you hit the one particular commit that the change got issued. And it's even better because Git bisect accepts a script. You can totally automate it. You can create a bash script that will verify is that commit correct or not, pass it to bisect, and you're running it, you're going grab a coffee, and at the end of the day, you're golden. You've spared an immense amount of time. And at the end, you're just doing a Git Bisect reset, and you're back on the head of your branch, whatever you were doing. A big time saver, believe me. So when do you know that the Git repository is too big? I'm going to give you a hint. When you're doing something simple like Git status, and it takes 2 minutes to finish. When you're doing a checkout branch, and it takes 5 minutes to finish. Something went wrong. Now, what happened? The guidelines say that the repository size shouldn't exceed 1 gigabyte. So, not so recently, I joined the project. I cloned the repository. I checked its size, 7.9 gigabyte. Pure Git content. So you started looking what happened. Taking a stroll through Git history, and I find that there are multiple binary files within the Git history. And by binary files, I mean zip archives, images, DLLs, precompiled library, exe files, whatever, executables. Whatever is compiled, Git does an awful job of tracking the changes within these files. So you shouldn't put that in Git. So if I'm working with a repository that takes me 2 minutes to even check the status of, well, we need to fix it, right? So let's find a solution. Let's make it smaller. I've started Googling, learning. So, OK, let's take the trash out. First suggestion, let's do a Git garbage collect. Run a garbage collector in an aggressive format just to remove the obsolete or dangling commits from the source structure. Didn't do nothing. Like maybe a kilobyte worth of space got freed. I'm working with 8 gigabytes. Like, nope. Going on. I tried repacking it. For those of you that don't know, Git uses an odd way of storing its objects. It's basically like a very old-style database. It uses page files to store the objects. And these page files may get fragmented the same as a hard drive. So Git repack is basically saying, hey, Git, do a defragment. OK, that has taken a really long time to run and didn't free nearly enough space. Like maybe hundreds of megabytes got freed. Nothing for me. So, OK, if I can't find a solution, and at this point in time I'm thinking that the Git repository history is sacred, as in we always need to have the ability to go back in time because a client may request a patch from somewhere way back. So maybe we should think it about other way. Maybe we should start cutting things out. Maybe there's something that we don't exactly need. And among different tools, and a small disclaimer, from this point in time, I'm talking a very destructive operations. I'm talking about a complete history rewrite. So if you have to ever do this, make sure you know what you're doing because you'll break something. I can promise you, you are going to break something. So there is a neat tool called BFG. It comes highly recommended. That allows you to basically delete anything from the Git history, not from your directory structure, your current project, but that's basically an amnesia button for Git. Git forget that you ever known that something like this exists. And after doing a BFG, you just need to do a reflog expire, because BFG just marks certain references as obsolete, and take the trash out, and your repository gets smaller. But as you may imagine, not enough. So maybe we can do something more. In the case of our project, that was that we were working on a framework. That the framework was the product, but it has its own test application in which we verified, and it was created for the testing purposes. And it resided within the same repository. So maybe extract that particular thing, but we want to extract it while maintaining the history. So create a new repository from the chunk of the old one while maintaining the whole repository. Yes, it's possible by using a filter branch. You can tell Git to scan the whole history of Git for any changes that touch that particular subdirectory and create a new repo. So basically, you've created a repository, push it out. OK, so now we're verifying. After cutting it out, we're checking a legacy commit, and it doesn't build because we just cut something out. So we need to go back and modify the contents of the commits because we removed a directory, so we need to alter some paths. So you can do that. You can use filter branch to run basically a script over your repository history to change something. And I'd caution you with one thing, that if you're doing it like that, it's going to take time. But it didn't save us enough time, so the last thing. Convert to large file storage. LFS is a mechanism added to Git or on top of Git that allows you to store files on a separate resource than a Git service. And it's transparent to you. It uses Git hooks. And you can easily convert your repository to your LFS by using BFG. You're just telling BFG to convert your repository to use LFS. And if you do something like that, please remember that your repository server needs to support LFS. And you need to push to a new origin because you've basically recreated the whole repository. You removed each and every commit and created new one in its place. So if you try to push it to the original point, you're going to break stuff. And that leads me to my last lesson. The repository structure should be designed and treated as an architectural artifact, as in you need to be aware of it, you need to maintain it and uphold it, because if not, you will end up sooner or later inflating a repository, and you'll end up doing the same problems over and over again. And use LFS. It's there for a reason. Thank you.